So let's take a look at this one. For a large sample size, which of the following gives the smallest margin of error when calculating a confidence interval or a population proportion? So for this one, we want to remember, first of all, what is our margin of error composed of? So we have our Z's number, our critical number, times our standard error formula. So we have to think mathematically here a little bit. Basically, as this part, my standard error, this number is going to remain constant based on my level. And so obviously I'm going to have some number here that's the same for Z, but this number could change depending on what P hat is, depending on my scenario. So what I want to think about mathematically is 0.5 times 0.5. That's the largest that P hat could ever be. It's like you have a percentage or proportion. So once you hit 50, the percent of successes is equal to the amount of failures as well, 50-50. So this is basically the biggest P hats we could have in here. Because even if we switched them successes and failures around, it's multiplication, it won't matter mathematically. So in this case, I want to look for an interval that has the smallest Z number, because that number won't change. So I'll have some small number there times some other small number is what I'm hoping to get the smallest margin of error. So 99 and 95 are out just because those are going to have larger Z numbers. So if we're looking at P hats that are the same, which make this part of the formula the same, and we can eliminate these choices since they have a larger confidence level, meaning a larger number here. So then the only thing we have is these two things. So for this one, we have different P hats. What we want to remember is that this part of my formula is going to get bigger and bigger and bigger the more like P hat gets closer to 0.5. Like this is as big as it could ever be. So we always want a small P hat. The smaller the P hat, the smaller this number will end up being. So we want option F or A.